So we've talked about doing so much work with quadratics that we can do it forwards and backwards. We multiplied and we factored, which was fancy division. Now we've been solving quadratics, and this lesson is about creating quadratics from those solutions. So we have been working with the zero product law, and that law says that we can find the zeros, and the zeros are also the x-intercepts. We also call them the roots, or the solutions. And we find those by factoring and then setting each factor equal to 0. So that means we can, if we have each of the zeros, we can kind of do this backwards. And that's what this is all about. We're going to start by doing a little review problem. Find the solutions by factoring. So x squared plus x minus 20. I'm just going to go ahead and recopy that. So I'm going to solve this by factoring. I need two numbers that multiply to negative 20. And add to positive 1. So to multiply to negative 20, my factor tree for 20 is 1 and 20, 2 and 10, 3 does not go in, 4 goes in 5 times, and there, if I start doing 5, then I start wrapping around to 4, so those are all my factors. If I'm going to multiply to a negative, I need one of my numbers to be negative. If my middle term is positive, I need my bigger number to be positive. So here, negative 4 and positive 5, that's my combination that multiplies to 20 and adds to positive 1. So I'm going to go ahead and flip those in my problem here. Negative 4x plus 5x. And then I'm going to break down that x squared, my negative 20. We are still set equal to 0 because we're solving, not just factoring. Split my problem in half. I can take out an x, my first two, I'm left with x minus 4. Bring down my middle sign. 5 and 20 have 5 in common. When I divide that 5 away, I'm left with x minus 4. That gives me x minus 5 and x minus 4 as my factored form. And then, if that's my factored form, to find my solutions, I just take those little guys and set them equal to 0. So here I switch the sign, or add 5 to the other side to find the solution, x equals 5. Oops, that should have been a plus 5, so sorry. Hopefully you were yelling at your screen just now. Maybe not yelling, thinking, what is she doing? So that should have been an x plus 5 there, since that was a positive 5. So I subtract my 5 over and get a negative 5. Here, plus 4, plus 4. So now, without even graphing this, here's what I know. I know that this graph crosses the x-axis at negative 5 and at positive 4. So my curve, my parabola, looks something like this. Pause the video for a minute and look for the relationship between our answers and our factored form. So here, if I have x equals a negative 5, I switch my sign and get back to factored form. If I have x equals 4, switch my sign, positive 4, x minus 4, and then back to factored form. That's what this whole lesson is about, being given the graph or just the solutions, the numbers themselves, and being able to find that factored form. That's all we're doing today. Okay, suppose x equals 3 is a solution. To get the solution, we must have solved the equation. Well, now we're working backwards. So if we had x equals 3, to go backwards, we had to move that 3 over. And anytime we cross that equal sign, we're switching the sign. So if this is a positive 3, that would have been a solution to the equation of x minus 3. Again, because we crossed the equal sign, we had to switch the sign. Just like we did when we were solving equations the first week of school. That means that x minus 3 is one of our factored pieces, is one of the factors of the quadratic. If the other root, or the other solution is x equals negative 2, again, to move that negative to the other side, the negative 2, we would have to switch the sign, so then we know that x plus 2 would be a factor. Because we're going over that equal sign. And now we could write factor form like this. X minus 3 times x plus 2. That, on the OSD, will get you full credit if you are writing out a factor, if you're asked for factored form. Now, it's really good practice to multiply here. And then you're all the way back to what one of our original problems would look like. So if we take x minus 3 times x plus 2 and multiply that out, x squared, 2x minus 3x minus 6, and then combine our middle terms. Negative 2 plus 3 is negative 1. So if we have a quadratic that has two solutions, and the solutions are x equals 3 and x equals negative 2, the original equation would be x squared minus x minus 6. Awesome, let's look at another scenario. Oh, verify our answers by graphing. So, before we look at that next scenario, let's pull up Desmos, and let's put in our final answer there. It was x squared minus 1x minus 6. And it better cross at x equals 3 and x equals negative 2. And it absolutely does. So you can draw that graph if you would like to, or you can just write here. We looked at it on Desmos. And we verified, oh wait, was it, now I can't even remember, positive 3 and negative 2. Check. So here's what we had. We started with x equals negative 2 and x equals 3. And to make our factored form from solutions, we put our x's in our parentheses, and then we switched the signs. So we started with a negative 2, it became a positive 2. We started with a positive 3, it became a negative 3 in our factored form. All right, let's look at another scenario. Here we're given the graph. So first, is this graph a function? And since it's a parabola, and we know parabolas are a function, we can say yes. It's a quadratic function. None of our x's are being used twice. State the x-intercepts. So we're crossing the x-axis at negative 3 and positive 1. Says use the x-intercepts from above to write this equation in factored form. Okay, so just like we talked through on the last problem, here's what I'm going to do. I'm going to write out factored form. I'm going to put my x's in the front. And then I'm going to switch my signs. It was x minus 3, so that's going to become plus 3. Because what I'm really doing is moving this 3 across the equal sign to be with the x. And when we move it across the equal sign, we switch our signs. This is a positive 1. To move it across the equal sign to be in factor form with the x, we're going to do minus 1. And now we can double distribute this and write a beautiful final answer. X times x is x squared, negative 1x, plus 3x, minus 3. Combine our middle terms there. Negative 1 plus 3 is 2x. And really it's equal to 0. And you could absolutely verify this by graphing. Again, Desmos is our best friend. This is x squared plus 2x minus 3. And we should get positive 1 and negative 3 as our roots. X-intercept, positive 1, negative 3. All right, go ahead and try the mixed practice. The solution for this is posted on Canvas. So go ahead and take a look at the solutions if you need to check your work. As always, Mrs. Margroff and I are here to help as well.